Okay, so we just started graphing this first piecewise function, and I forgot to hit record to start with, so we plotted this point, and this point, 0, -1, came from plugging 0 into the top part. Now, this less than tells us we can only go left with this function, because that's where the x values are left. So the slope is positive 1. Normally that means I go up 1, right 1, up 1, right 1, up 1, right 1, but I can't go right. I have to go left. So what do I do?
Up one left.
Up one left, down one left one.
Down 1, left 1. We do the opposites. Okay?
How'd you know to use one, like?
This has a slope, an understood slope of 1. Okay, so that's my left side, which was the line. Now, this second piece, the quadratic, is on the right because that has greater than. Same thing though, you plug in the 0. This is my x value where it starts. And 0 squared is 0. So there's a point right here at 0, 0. Alright, now this is a quadratic though. And normally, if I went left 1, square it, go up 1. Right 1, square it, go up 1. But I can't go left. I can only go right. So I just go right 1, up 1. Normally with a quadratic, I'd go left 2, up 4, right 2, up 4. But because I can only go right, I just do right 2, up 4. So this quadratic is only the right side of the parabola, because it's for x values that are greater than or equal to 0.
So what's this? What was the slope?
On the quadratic, we don't have a slope. We just have our moves. 1 squared is 1, 2 squared is 4, 3 squared is 9. The only one that has a slope is the line. All right, so this is the idea that we're building to. Okay, and this is what we're really going to focus on Monday. But I wanted to get it in your brain, let it settle, and then Monday we're really going to talk about, okay, how do we do this one? How do we do this one? What changes? We got to be careful. This tells me the right side. This tells me the left side. Now this one is not continuous, just like the functions on the other page, except for that middle top one were not continuous. This one has what's called jump discontinuity, because we have to jump from here to here. Alright, the last thing we're going to do today is the reverse of what we did yesterday. So yesterday, I gave you absolute value, and you broke it into piecewise. Today I'm going to give you piecewise, and we're going to put it back together and make an absolute value. Now, after doing what we just did, this is a lot easier, because we know that on our absolute value, the vertex is always that point where we can draw the line that separates the two. So, do you see if I plug 1 into this first equation, I get the point 1, 3. And the bottom one also has 1. And if I plug it in, I get out 3. When I plug in this x value for a piecewise function, an absolute value that's been written as a piecewise, it always gives me the vertex. So plug that in, gives you the vertex. I know it's going to look like this. This is vertex form for an absolute value function. Now the only thing I have to worry about is what is A? Does anything go out in front? And this is what you do every time. You look at the right side. This is the right because it's the greater than. We look at the right side, and whatever this coefficient is of x is what goes right there. Now let's prove it. We know the vertex is 1, 3. The left side says my slope is positive 1. So I'm going to do the opposite to go left. The right side says my slope is -1. And from the piecewise function, it graphed that. Is this the equation for that absolute value function? Yes, it is. Okay, so step 1. Plug in the x to find the vertex. Okay, so here's the x. The x is 2. If I plug in 2, 3 times 2 is 6, plus 1 is 7.
I have a question.
Yes.
Is the left side the y and the left side the x and the right side the y?
No, the left side is the less than part, and the right side is the greater than part.
I know, but how do you? I'm talking about the vertex.
For the vertex? Okay, so this is always the x at the vertex, and you have to plug it into either one, because you get out the same thing.
Okay.
You plug it in here to get out the y.
Okay.
Okay? So, now I can start setting up my function. Okay, so we found the vertex. And so, we're going to plug the vertex into the function. That's supposed to be a shortcut for absolute value, but it just looked like parallel lines. So I'll write absolute value. Alright, and then last thing is to take the coefficient from the right side. Alright, so let's look at this. This is less than, so that would have to be left. This is greater than, so this is the right side. What is the coefficient? -3. Okay, so earlier I told you what was not your homework. Now I'm going to tell you what is, and hopefully you'll get to finish most of it in class. The back of yesterday's notes. Okay, so it looks like this, guys. Starts with number 6. You're going to do 6. You're going to finish up the fact. And then on the sheet you picked up today, 12 and 13. So you're doing numbers 6 through 13. And that's it. Alright, so Monday we talk about piecewise. So get a lot of rest this weekend. Come ready and excited to learn.